This question is about tension on a string and friction. If you have two blocks set up in this situation where one's on a flat surface and the other is on an incline, one has static friction and the other doesn't, what mass can M2 be given that mass of block 1 is 2 kilograms and its static friction coefficient is 0.5 and the angle of incline is 30 degrees? It's best to draw a free body diagram in the situation. So if we start off with M1, we just have a block where it has its weight, which is M1g, and then it has its normal force, Fn, which is also an equal to magnitude of the weight. And then we have static friction going this way, so we're just going to call it friction. And then we have the tension of the string, which is equal to some value that we're going to figure out in just a second. Now, if we do the free body diagram for M2, let's draw it on an incline like this. We have M2. Now, weight is still pointing down this way, mg. Now, let's get actually the components of this, because we want the components that are parallel to the incline and perpendicular. So we're talking about these components right here. Right here. So that's basically what consists of this weight. Now, given this is a right angle, this theta right here, so if we drew this right like this, essentially, the theta that's over there is equal to this same angle. And so we can actually say that M2 cosine theta, which is this, is basically equal to the force going that way. So this is equal to the normal force that M2 has from the incline. And M2 sine theta is pointed this way. So that's the weight by gravity causing M2 to try to slide down. So this tension right here is also equal to M2 times mg, or I forgot to actually multiply this by gravity because it's a weight. So we have M2g sine theta. So we have the tension on the string on M1 is equal to M2g sine theta, which is paired up perfectly with friction. So these two values are equal to each other. Now, if we want to find what mass M2 could be, well, we have an equation here. We have friction is equal to M2g sine theta. So if we set this up, we would end up having M2g then sine theta is equal to the friction. So the friction is the coefficient times the normal force. So the coefficient of M1 times its normal force, which is M1g. Now, let's just start plugging in. So we have M2 times gravity, 9.8, times sine of 30 degrees, which is 0.5, is equal to the static friction coefficient, which is 0.5, times M1, which is 2 kilograms, times g, 9.8. And if we solve for M2, we get that M2 is equal to 2 kilograms. So that's the biggest part in this situation, is getting these components of the weight on M2, where we have M2 cosine theta g is basically equal to the magnitude of the normal force on this surface, while M2g sine theta is equal to the weight that's pulling it down the incline, which is also basically equal to the tension on this string. So say we actually increased the static friction. Say we added static friction to M2. Could we increase the mass of M2? Well, of course, because now not only do we have a tension force pointing this way that's keeping M2 from sliding, but we also have static friction going against the direction of M2g sine theta that's keeping it up. So we can actually increase the maximum M2 given that this incline had actually a static coefficient of friction.